Hi Math 8 students, today we're taking a look at right triangles. In a right triangle, the sides that form the right angle are called the legs. So these sides here are the legs of the right triangle because they make the right angle. The side opposite the right angle is called the hypotenuse. Think of hippopotamus, hypotenuse. And in a right triangle, the hypotenuse is always the largest side. Let's see some more. In each of the following, record the measures of the legs and the hypotenuse. So you should be able to distinguish which are which given any right triangle. So in this case, the legs are 5 centimeters and 12 centimeters, while the hypotenuse, the one opposite the right angle, is 13 centimeters. So from here, you're going to try numbers 2 and 3. In each of the following cases, find the area of the squares attached to each side of the given right triangles. So while we're doing this, we're going to be looking for a relationship to see if we can come up with an equation that can be used to find the side lengths of any right triangle. So in this case, we have a square that's 4 by 4. And to find the area of a square, we just multiply those sides. 4 by 4 is 16. So this square is 16 centimeters squared. Then this bottom square is 3 by 3, making that 9 centimeters squared. And the largest one, the one with the hypotenuse, is 5 by 5, making it 25 centimeters squared. Now look at those numbers closely. Do you see a relationship between the side lengths and the larger length when we're looking at the area of the squares? Keep that in mind for later. Let's try another. So here, doing the same thing, we start by squaring the lengths of the sides of the legs. And again, this bottom one is 5 by 5, which is 25 centimeters squared. The next one on the side is 12 by 12, and that squared is 144 centimeters squared. And then the largest one is 13 by 13, making that 169 centimeters squared. So again, look to see if you see a relationship in these two areas with this area. Keep that in mind for later. So you're going to try 7 through 10 on your own. Pay attention to the questions in the Go formative to help guide you to find your correct answers. So now, a Pythagorean triple is a set of 3 numbers listed as A, B, and C that form right triangles. Any multiple of a Pythagorean triple will have measurements that will also form right triangles. So here we have 3, 4, 5. And similar to what we did with those triangles before, if you square 3 and square 4, you should get the same square as 5. So 3 squared is 9. 4 squared is 16, and 5 squared is 25. And 9 plus 16 is 25, proving that the side lengths of 3, 4, and 5 make a right triangle. And the next one, we have 5, 12, and 13. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. And if you add 25 and 144, you get 169. Proving again that the side lengths of 5, 12, and 13 will make a right triangle and can be considered what is known as a Pythagorean triple. Then the last one, we have 7, 24, and 25, 7 squared being 49, 24 squared, 576, and 25 squared, 625. And if you add 49 and 576, you get, again, 625, proving that those 3 side lengths, with the largest one being the hypotenuse, would form a right triangle. So now we're going to use those Pythagorean triples to find some other lengths that would make a right triangle. For 11, we have give a multiple of 3, 4, 5 and show that it also forms a right triangle. So since 3, 4, 5 is a right triangle, or the lengths of that would make a right triangle, any multiple of those three should also make a right triangle. So for example, if I multiply these all by 5, I get 15, 20, and 25. So now if I square them, 15 squared plus 20 squared should equal 25 squared. Well, 15 squared is 225, and 20 squared is 400. And I know that 25 squared is 625. So obviously, if you don't know those squares off the top of your head, you can use your calculator. But if you do know them, go ahead and work right on. Then 225 and 400 equals 625, which proves that those three lengths are Pythagorean, do represent a Pythagorean triple, because they will form a right triangle. Let's try another. In number 12, we have 5, 12, and 13, which we also know is a Pythagorean triple from earlier in the lesson. So we're going to show again that a multiple of 5, 12, and 13 will also be a right triangle. So I could multiply these all by 3, or any number. I'm just choosing 3 to work with for right now. 5 times 3 is 15. 12 times 3 is 36. And 13 times 3 is 39. So now I have to square them. So it would be 15 squared plus 36 squared should equal 39 squared for this to be a Pythagorean triple and form a right triangle. I know 15 squared is 225. The next two I don't know off the top of my head, so I'm going to use my calculator. I can do 36 squared, which is 1296, and 39 squared is 1521. Then if I add these two, I should get that 1521. But let's check. 6 plus 5 is 11, carry the 1. 2 plus 9 is 11, plus 1 more is 12, carry the 1. 2 plus 2 is 4, plus 1 more is 5, and bring down that last one. So we got 1521, which again proves that 15, 36, and 39 will make a right triangle and is a Pythagorean triple. Again, because it is a multiple of the base triple 5, 12, 13. So you are now going to try 13 and 14 on your own. Of course, I'll be around to help you guys out, so don't hesitate to ask questions if you need to. Good luck!